All right, guys. Hi, welcome to Numbers. Let's talk about the first mock cat. You can just go to numbers.com and you'll get all the details and stuff like that. Anyway, the first free mock cat latest pattern. Let's talk about it. The modern pattern, like where we have a calci and everything like that. Remember one thing: when you have a calculator, keep one thing in mind that you will not have any calculation questions. That's like an insult. Okay, no calculation questions. Okay, this won't be there. Anyway, so we'll have all concept based questions, but the first mock we've kept it a little simple, easy, because it's like just August and the cat starts in November and stuff. I mean, cat's in November, so it doesn't start earlier. Is to start like because we have 21 days of cat. Now we just have one day. So November 29th is when you'll take a cat. That's perfectly fine. Anyway, come back. So we have this three things here. So you can just go to the mock test, and I tried attempting. I scored -1. All right. So today I'm going to discuss strategies. Okay. One first thing we're going to discuss today is like strategies. Okay. How to exactly strategize your quant. Okay. Number two we're going to discuss is only quant today, because I thought like precisely because first discussion. So it's like DI, LR, and verbal. I mean, you first need to know the strategy of attempting a mock, and then we can take it ahead. So we'll keep three discussions for this particular mock. Okay. One would be on quant. Well, obviously, we'll take it today, and one would be on DILR, and the last would be on verbal. Anyway, so coming back, strategy. I'll discuss quant, and I'll discuss how do you reject questions. All right, and what should be the rejection time exactly. Okay. So rejection time, and we'll talk about that. Anyway, so let's go back. Okay, so now with this is the mock. You can see the leaderboard here. Okay, leaderboard is basically who scored the top 10. I was supposed to keep everybody's information out here, but then I thought it's better if I keep top 10, because little you can also have discussions here. Discussion is like, for example, let's say question number 72, you have a doubt. I can immediately reply to you, and you can also make notes for yourself. For example, let's say in this mock, if just in case if we've used Wilson's theorem, we can just make a note of that Wilson's theorem, and it'll be beneficial for you in future. Anyway, so coming back, so all right, just a minute. Uh, all right, so you just come back to it. So we've been live streaming this, and this is the first live stream that we have with the mocks. So we'll have almost certainly everybody having a live stream eventually. I mean, for every mock, sorry for everybody, every mock live stream eventually. Anyway, so perfectly fine. This is okay. My streaming is perfectly fine. So you probably watch this video at least 360 pixels, 360p or more resolution. Anyway, coming back to the point. So let's reattempt the mock. So okay, we have an option of retaking the test. So we can retake the test. Okay, if you wish to like apply a strategy somewhere in another way. Okay, because for cat we have at least, okay, for cat we'll at least have around 4 to 5 strategies that I'll discuss eventually, and let's see how this works. Anyway, so coming back to the mock, the retake test. So this is like general instructions, and white means you haven't visited the question, green means you have answered it 50 sorry, purple means you have answered question but marked a review, red is not answered, and not answered but marked for review. Okay, so it'll be a complete quant. Okay, now what do I do is I normally have a 2 round strategy. Okay, so it's called the 2 round. Okay, in the first round you're supposed to attempt the following things. Number one liners, if they are easy. Not necessarily every one liner is easy. Number two, the areas you're really strong at. Okay, I'd suggest strong areas. Okay, for example, you may have something like some people have geometry a strong area, some people have numbers strong area, some people might have arithmetic strong areas. Okay, anything like that. Sorry for that. So one liners, strong area, and the last, okay, is the end question and questions that involve other variables, okay, or continuation. I would suggest not n is anyway a variable, so continuation questions which have dot dot, okay. So they'll have like this, like, if n factorial is, whatever, blah blah blah, dot, okay, something like that. We will talk about these questions in future if we have a few in the box. Anyway, but you'll have at least one in the mock every time. Okay, so let's talk about it now. Question number one: number of positive value pairs x and y satisfying 4x minus 17 minus 1 and x is less than equal to 1000 is. Now this is like one equation and two variables, so it'll definitely have. Now whenever you have one number of equations, keep this in mind, number of equations is less than the number of variables, you have infinite solutions. Very simple reason. Okay, so solutions are infinite. Very simple reason. Let's say I have a graph here. So I have a line. Now the line has two variables, x and y. Okay, but if I have only one line, I can have every point as a solution. Okay, so that's the point. So that's why you have infinite solutions. All right. But they'll have some constraints. For example, this question has some constraints, so we'll not touch this question right now. This is called special equations. We'll not touch it right now. So let's go to the next question. Second question. You can scroll from this tab here. Okay, ABC distinct digits. Consider a two-digit number AB and a three-digit number CCB. Both defined under the decimal system. If AB square is CCB. Now, they're saying that AB square is CCB. Now, this question is attemptable because you have a square of two-digit number giving you a three-digit number. Now, obviously, the first two-digit number that's whose square is a four-digit number is 32, 1024. All right. So definitely the number is going to be less than 32. AB is going to be less than 32. So very attemptable question. You have 31 options and you can just probably skim through all that. Better than that, remember squares. Okay. If you notice carefully, 21 square is 441. See, AB is 21 and CCD because CC. So you have first two digits similar, which is 44. Okay. If you remember squares very well, you can easily estimate this. AB is CCD. AB square is CCD, which means CC has to be like a a three-digit number CCB, which CC is similar, which means 4 and 4, 41, 441, 44 and 441. And they've also mentioned CCB is more than 300. So you have a lower limit and the upper limit as well. Okay. The answer is value of B is, so B is going to be definitely, it is a square of 21. So B is going to be 1. All right. So I can mark 1 here and I can just save my answer. Keep in mind, just keep saving your answers. Okay. Whenever you do that, and they'll turn green, which means you've answered that question. All right. Remainder. Now, remainder questions are the easiest questions. Okay. You either have Euler, Wilson, Chinese remainder, or basics of remainder. Okay. Now, the question here was 7 power 84 divided by 342. Now, first 7 power 84 divided by 342. You always first check for the basic remainders. Basic remainders is where the power of the numerator, okay, so 7 power 1 is 7, 7 power 2 is 49, 7 power 3 is 343, and 7 power 4, if you, just in case, no, you must know the fourth power of one digit numbers at least. I mean, single digit numbers, right? Because it's very, very easy, because single digit numbers usually, all of them have squares in two digits, so the power is just square of that. 49 square is 2401. Okay, you check whether a power of 7 is near 342, and 342 is obviously the previous number 343, so we can use that. So we have simple 7 cube. All I got to do is check whether if 84 is a multiple of 3. If it is not a multiple of 3, I can't do much. We just have to split it. Okay, but coincidentally here 84 is a multiple of 3. 84 is 3 and 28, okay, over 342, and I then have 343 over 28, raised to 28, divides 342. This remainder is going to be 1. So 1 power 28 is definitely 1 as a remainder, and we can just quickly mark that answer as 1. All right, let's go further. Now this question says, now let's say if PNC is a strong area, this question becomes brilliant for you. Okay, 10 points are marked on a straight line, 11 are marked on another straight line. How many triangles can be constructed with the vertices? Now for triangles precisely, we need 3 points. So 1, 2, 3, and we have a triangle. Okay, because triangle is basically a plane. Okay, any plane, you just need 3 points to define plane. So the question says that there are 10 marked on straight, 11 marked on another straight. So there are 10 points marked on straight. So let's say the straight line, and we have 1 here, 2 here at the extreme, 3, 4, 5, 6, 7, 8, 9, 10, and we have another 1 here and 2 here and 3, 4, 5, 6, 7, 8, 11, 7, 8, 9, sorry, 10, 11, sorry, I was just rushing to the answer. Okay, so we have 10 points here and 11 points here. Now the rule of combinatorics says that you're not supposed to consider these to be on straight lines initially. You're supposed to be consider all 21 points are scattered. If all 21 are scattered, obviously will form 21 C3 triangles. But these 10 points are on a straight line. So we won't count these 10 points. I mean, because these 10 points, let's say for example, this point, and let's say this point, they don't form triangles. But we've counted them in 21. 21 C3 is basically an assumption that all 21 are scattered and we count all the triangles possible. But the 10 points on this line don't form triangles with each other. So we'll subtract the 10 C3 because we consider them here. All right. And then same goes here. 11 points. Let's say I consider this point, and let's say this point. These points don't form a triangle. So I'll subtract 11C3 because I've assumed in 21C3 that these 10 points here and these 11 points here also form triangles. All right, and you can just use the calci here. I mean, yeah, so that's a new thing, calci here, and you can just calculate 21C3, and I mean, you can calculate 21C3. It's going to be 21 into 20 into 19 divided by 6. Okay, so 1330, and you can multiply that to the other thing and you'll get the answer. All right, cool, let's go ahead. So we have the fifth question. Okay, now the fifth question is actually, I'll review that later because you're not supposed to solve that in the first round because a little like a little conceptual kind of question. Let's go to sixth question. Speed of railway engine is 42 per hour when no compartment is attached. So when it's just engine, it's 42 kilometers an hour. Reduction is proportional to square root of the number of compartments attached. So there's a good information. The reduction of speed, okay, I'll say, let's say R is directly proportional to square root of the number of compartments attached. Okay, let's see how this works. So we have, okay, directly proportional. So no inverse proportion. What is the rule of direct proportion? Rule of direct proportion says that whenever there is direct proportion, the ratio is constant. Okay, it won't change. For example, if I say A proportion to B, okay, when A is 4, B is 8, when A is 5, what is B? Okay, now this is double, so this has to be double. So the ratio remains same. All right, let's talk further. So there's 42 kilometers when no compartment attached. So we'll not consider that for now. Okay. If the speed of train carried by an engine is 24 kilometers with 9 compartment attached. Okay, so now the reduction in speed is basically it went from 42, sorry, to 24 when 9 were attached. Okay, so basically we're talking reduction. Keep that in mind. Here we're talking reduction, nothing else. Okay, so reduction is how much? 18. 18. Now again, 18. How do you get 18? 40 to 24. Two numbers reverse of each other. Okay, their difference is going to be a multiple of 9. All right, it depends on what multiple of 9 depends on the difference. Okay, so its difference is 2, so the difference is going to be 18. Okay, difference of the digits, 4 and 2 is 2, so that's why 18. Okay, so reduction is 18 when there are 9 compartments attached. So I'll say square root of 9 is 3 because I want root of 9 and not n. Okay, so that is equal to let's see further. All right, maximum compartment attached. Maximum compartments means what? The reduction should be 42. The entire speed goes down upon root n. This is 6. This is 7. So root n is going to be 7, which means n is going to be 49. If n is 49, at 49 the reduction will be 42. Yeah, because 42 is what we assume the speed here. But 42 will halt the train. Okay, but the question says the maximum reduction attached is carried by the engine is how much? Okay, so which means we don't want the train to stop, so we'll keep one less. It's going to be 48 because at 49 the train will stop. It'll be the entire speed of the engine will get reduced. sorry for that. Okay, the entire speed will get reduced. Okay, we don't want that to happen, so what we'll do is we'll keep it like 49 is when the speed will be 0. We don't want 0, so we'll keep it 48. I think you got the point. Okay, let's talk further. Total expenses of boarding, we partly fixed. Average expense 725. 650. Okay, actually it's given the other way. So we've reviewed this question further, so we'll not talk about it right now. Let's go to question number 8. 40% employees of certain I mean, the seventh question that we're talking about, the data is actually exchanged, it seems. Okay, so it should have been the other way, basically. Okay, let's talk further. So eighth question: 40% of the employees of certain company are men. 75% earn more than 25. If 45% of companies earn more than 25, what fraction on 25 or less? A very simple question. When you have this kind of very basic, that's why I told you in this mock, whatever you score, multiply that by zero point 0.7. That is going to be a real score, because the mock is actually, like, I would say, easier than cat. Why am I emphasizing on this? Is because it's a first mock, so you got to be like a little like, like you got to be like a little okay, because you're not that completely and thoroughly prepared. It's the month of August. Anyway, going further, so the question reads: 40% of the employees. Now, whenever you have something like employees and this much are males, this much female, assume 100. It's simple. Okay, so males are going to be 40%. There's 40. Okay, females are going to be the remaining, which is 60. So I'll write down females are going to be 60. All right, let's talk further. What the question says. The question further says that 75% of men earn 25 or more. So 25 or more will be 75%, is 30 people. 75 is 3/4. Okay, so 30 earn more, so 10 earn less, whatever, doesn't matter, but just in case. All right, if 45% of the company employees earn more than 25 a year, so totally 45 earn more than 25 in the entire 100. These many earn more than 25, but in males only 30 earn more than 25, which means the rest will be females. So 45 females earn less than or equal to 25. So the fraction is 45 over 60, which is 3 over 4, and that should be the answer. And precisely we can just mark it 3 over 4. Okay, cool. Okay, these questions, keep in mind, when you go to first round, you're supposed to solve questions which take less than the usual time. The usual time in CAD is, this year, 60 minutes for 34, which is approximately 2 minutes or a little less than 2 minutes for one. So if you can solve a question less than 2 minutes, that should be your first round question. All right, how do you get that? Now, what is the rejection time all about? Now, rejection time in this case should be 20 seconds. This 20 seconds, you should be able to read the question, interpret, and decide whether if you want to solve this right now in the first round. Okay, rejection time in the first round, 20 seconds. All right, let's go further. So these are all first round, we can solve easily in the first round. Now this is like mods, so we'll not touch it in the first round for now. Okay, I'm not saying it's easy or difficult, but we'll not touch it. Let's look at this. If n is equal to 1 plus x, where x is the product of 4 consecutive positive, which of following is true? Incomplete data question, by the way, so you can mark that as a review. Okay, you're supposed to like, I've given this to my technical team, they'll work it out. 11th question. Okay, for two positive integers a and b, define the function HAB as the greatest common function, which is GCD or whatever, greatest common divisor, greatest common function, doesn't matter. Okay, because it's a very silly question. Let A be a set of n positive integers. GA is the GCF of elements of A compared to represented using function H. Minimum nothing used to compute function H. Very easy question. See, understand this. Now, when I look at this question, this is similar to like cat to the egg question. This is one of the cats that I attempted. I mean, for the first time. Okay, I scored a 99.94 in this. Okay, anyway, it doesn't matter. The point is very simple. You just have to observe one thing. Let's say this is called the induction method. Okay, where you have, like, this is supposed to be solved in the first round because this belongs to the question called the n question, like, the n elements and stuff like that. All right, so let's say I have just 3 elements or maybe 4 elements. Okay, first time I'll compute for them, I'll get another element. Let's say I define it as some number I want, like 11, let's say. So I have 11 3 4. The next time I do it, I'll do for 11 3. I'll again define it as 12 because I'm scared of variables. I take numbers. Okay, 12 and 4. And let's say I define for 12 and 4 and I can take a number, let's say 3 again. Okay, so basically for 4 numbers I got the output by doing the operation 1, 2 and 3 times. So if there are n numbers, I'll get the output by doing it n minus 1 times. Very easy again. Okay, geometry, If it's a complicated one, we'll not do in the first round, but we'll not talk about it right now. I mean, let's not touch it right now. Okay, you may have a complicated one sometimes. Three label boxes, red, white, balls up, misbehave. I mean, this question, for example, okay, you can solve this question like, I mean, if you know the question, I mean, you should have at least out of 34, okay, reading enough material, you should have 6 to 8 questions that you're familiar with. Okay. Now, this is a very familiar question. I'll explain this question to you. It was asked in Snap in 2007 and 8 and 9. I'm not sure. 8 or 9, maybe. Let's say there's one box containing gold coins, one box containing silver coins, and one box containing, we've done this in class, gold or silver or mixture coins, basically fewer gold, fewer silver. Okay, now how many boxes you need to open to find out? I mean, when I say open, you can just pick out one coin from each. Okay, so only one coin. Okay, so how many boxes you need to open to find out which, I mean, the labeling are incorrect. So gold is not labeled gold, silver is not labeled silver, gold and silver, which is mixture, is not labeled mixture. There's a mixture, there's silver, and this is gold, but they're not labeled correctly. Okay, they're labeled like gold maybe here, or silver maybe here, or something like that, mixture maybe here, anything. Okay, so precisely how many boxes you need to open to find out what is in what? Okay, uh, usually the answer that comes out like in everybody's head is two, because you need to have two at least to confirm it. Okay, actually the answer is gold or silver, only one box. I'll tell you how. What you do here is the way, it's actually not a quant question, it's actually a logic question, because what you do here is, uh, you find out the other way around. For example, this is labeled gold, this is labeled silver, this is labeled mixture. If this is labeled gold and it's incorrect, it's going to be either silver or mixture. If this is labeled silver and it's incorrect, it's got to be either gold or mixture. This is labeled mixture, it's incorrect, it's got to be either silver or gold. All right, let's talk. Okay, let's assume, let's, because they're asking for minimum number of boxes you need to open to find out what is in what. Okay, let's talk one by one. Okay, let's talk the minimum. I mean, zero cannot be the answer because you got to open at least one box. Okay, let's say one. Can we find the answer with one? Let's assume it this way. Okay, now let's say I open this box, so I take out one coin from this box. Let's say it happens to be a silver coin. Okay, if it happens to be a silver coin, I definitely, sorry, let's say it happens to be a gold coin. If gold box that is labeled gold, which is incorrect a label, gives gold coin, you know this is a mixture. If this is a mixture, this cannot be a mixture. If this is a, which means this has to be gold. If this is a gold, this cannot be this cannot be gold, which means it has to be silver. So you got all the points. I mean, mixture, gold, silver. But let's say, okay, let's say for example, gold mixture and silver gold. Okay, let's say for example, you get a silver coin out of this. Then there's a confusion. It can be either a mixture box or a silver box. So you can't really say which box is it clearly. Okay, so gold is out of the question. Let's say we open the silver box, which is labeled silver, but it's not actually silver, and you get a silver coin out of it. If you get a silver coin out of it, sorry, you know this is a mixture for sure. Can't be gold. Okay. If this is a mixture, this becomes silver. I mean, sorry, this becomes silver. If this becomes silver, this becomes gold. Perfectly fine. But what if you get, okay, a gold coin out of this? You can't comment anymore because it can be a gold coin, a gold box, or it can be a mixture box. So you can't comment. Okay. So the idea of removing one coin from silver is also gone. Finally, we come to the mixture box. If I remove a gold coin, I know this is gold. If this is gold, this is mixture. If this is mixture, this is silver. Just in case a silver comes out of it, this is going to be silver. If this is silver, this is mixture, and this is mixture, this is gold, and we get sorted. So removing one coin out of the gold or silver box, which is the mixture box, will help. And that's the answer, red and white. All right, let's go further. So let me see the activity. All right, so cool, very nice, very nice. 35 people already viewing it. A and D have to be different. Not really, Dipesh, not really, because can be asked in any manner. It can't be. Can it be one? No, it cannot be 225 Karishma because of the reason that CCB is more than 300. Yeah, I know 225 is also one of the options. Anyway, coming back to the point. Oh, brilliant question again. Keep in mind, there's a golden. There are some special numbers and stuff. For example, 11. 11 square is 1, 2, 1. Okay. 1, 1, 1 square is 1, 2, 3, 2, 1. Whenever you have only ones and you want to square it, they will go till a number that the number of ones are 4 ones here. So it'll go till 4 and then return back. So if I have 5 ones, it'll go till 5 and then return back. All right. So now here it's going till 8, so it's got to be 8 ones, and that's the answer. I mean, precisely, there are certain questions like these that you should know. This is like precisely another question. You can solve this by yourself. It's not a big deal. uh, let's talk about the this. I won't touch because it's a long question. It's a time speed distance question, arithmetic question, long question, so we won't touch it right now. Let's go ahead further. So this is like circle of radius 1 and everything like that. Again, geometry question, a huge data given to you, so we won't touch it right now. Let's go further. So we'll save it next. And 10 coins are distributed. Uh, Something like that. It's a long data given again. We won't touch it right now. So further, let's go more further. So here we have again the same question repeated. So it's 3 questions here. So Rupa leaves her home. Not don't touch it because huge question again. Huge question again. Little like 3-4 questions in the same set. Don't touch it. Don't touch this as well. All right, don't touch this. And yeah, so that's precisely it. Okay. So wait a minute. No. Okay. I'm in the last question. So what? Okay. Anyway, so coming back. So now in the first round, okay, ideally in the first round, you're supposed to attempt somewhere around 5 to 7 questions. Okay. I'll tell you the estimated time taken for the first round. The estimated time that you should take for the first round is somewhere around, let's say around 10 to 15 minutes, not more than that. Okay. And should be enough. Let's go further. Okay, so now the second round. Now the second round, you should always have a habit of mark for review. Okay, so you know that these questions I can solve. Okay, this turns a little purplish. Okay, and the borders turns purplish, and you should always mark for review, something like that. Okay, always keep that in mind. So that in second round you just come to these questions first. I won't define the third round or something, but I'll just suggest one thing, that once you go in the second round and you mark for review these kind of questions, okay, all you got to do is first jump to these questions and then go further solving other questions. Okay, so for example, let's say question number 6. Okay, we've solved it already. Question number 5, we haven't. 7. So here what happens is the confusion is we solve more questions, but I just marked 4 of them because the rest I did not use a calculator. Point is around 6 to 7 questions should be enough. After that, when you scroll through the entire paper in the first round, you must mark for review the questions. Okay, let's see how this works. Now, question number 4 is already solved. Question number 5, 6, 7. I do 7 is a little glitch. 8, 9, and yeah, we saw the ninth one. So if r minus 6 is 11, mod of r minus 6 is 11. So when I say mod of r minus 6 is 11, what do you mean by mod? Okay, now commerce guys, don't get scared, first of all. Okay, mod means the output can be, now the input, sorry, can be either positive or negative, which means r minus 6 can be, sorry for that, r minus 6 can be either plus 11 or minus 11. If it is plus 11, r is going to be 17. If it's minus 11, r is going to be minus 5. Minus 11 plus 6 is minus 5. Okay. So we found 2 values of r. 2q minus 12 is 8. Now if I have 2q minus 12 is 8, now keep in mind, it doesn't really matter. Okay. Mod doesn't matter. You can cancel 2 here. So I have q minus 6 is 4. So q minus 6 can be plus 4 minus 4. All right. And q in that case, plus 4 in that case will be 10. Minus 4 in that case will be 2. Okay. So now q has a peculiarity. It has both positive values and r has one negative. Okay. Let's see what you're supposed to do. Supposed to find the minimum value of q by r. Now if I want to find a minimum value of q by r, what is minimum value? Q should be the max and r should be the minimum. Because when you talk about numerator and denominator, for example, if I have 4, sorry for that, 4 divide 1 and 4 divide 2, obviously this is more because the denominator is lesser, right? Same goes for numerator. If I have 5 divide 2 and 5 divide 4, this is 2.5, this is 1.25, which obviously is more, which means denominator, if it increases, numerator remaining the same, okay, um, the value goes the other way, and denominator, I give the same example, sorry for that, both ways. But if I have the same fixed numerator denominator, 5 by 2 and 7 by 2, this is more, so numerator must be more, denominator must be less. So q has a higher value 10 and r has a low value -5. So the minimum possible value of q by r is -2, and that's how it's done. So the answer is -2. So you can spend some decent time out here and get the answer. All right, and save it next. Okay, this question doesn't have any options, so we'll not go there. All right, geometry we can touch later if we have something else to do. All right, let's say we want to do something like question number, this question, because see, this question has 3 questions on it. Okay, so we definitely go for question number 19. Okay, let's see, because the data is lesser. Okay, 10 coins are distributed among 4 people, PQRS says that each one of them gets 1 coin, another gets 2 coins, third gets 3 coins, and the fourth gets 4 coins. Now if 4 people are getting 10 coins, one of them has to be 1, 2, 3, and 4. Yeah, because I mean each one of them has to be this, because 10 is like 1, 2, 3, 4, simple, right? Let's see what is being asked further. It is known that Q gets more coins than P, so I'll make the data note of that. Q is more than P. And the last is the second thing. This is what is supposed to do in the rough work. Whatever I'm doing here in the note is supposed to do in the rough work. Okay. S gets fewer coins than R. So if S gets fewer coins than R, so R is more than S. All right. Okay, let's talk further. Let's look at the question. If number of coins distributed to Q is twice the number of coins to P, okay. Now Q is more than P, so Q has to be more than P. I mean, so Q cannot take obviously 1 because 1 is the least. Okay, so Q can be 2 and P can be 1. So if I have this, basically twice of P basically means Q has to be an even number. So Q can be here or Q can be here. Okay, so I'll just a minute. I'll just drag this off here. Okay, so if it's either Q here and P here, or Q here and P here, all right. So in any case, let's see. We'll follow necessarily true. R gets an even number of coins. Now, what is R? R is the other two guys left. R gets even number of coins. Not true at all, because in both cases, R can be here, but R can be here too. Okay, but R cannot be here. So R, in this case, R has to be here. But in this case, R is here. So R can get an odd number of coins because R is more than S. So R has to be like either this way, RS, or RS, right? So not necessarily true. Necessary true is like, because we have both two cases, it should be true in both the cases. Right. Next, R gets an odd number of coins. Again, the same thing. It cannot be true always, because here in this case, R gets an odd number of coins, but here in this case, R has an even number of coins. So we cannot be definitely. Definitely true basically means it is true in all cases. All right. Talking further, S gets an even number of coins. Now S, for example, in this case, RS, in this case, RS, sorry, RS. So S cannot have an even number of coins at all, because in both the cases, S has odd number of coins. Okay. Let's talk the fourth option. So fourth option, S gets odd number of coins. Yeah, because in both cases, S gets an odd number of coins, because R should be more than S here. It's clearly stated here. So R is more than S. So S has to be the smaller number. Okay. So R has to be always on right. Definitely, that's the answer. Save it next. If R gets at least 2 coins more than S, then which is the following necessary true? Now R gets at least 2 more than S. Okay. Now in this case, we're not supposed to assume the previous case. Okay, because that was the question meant for question number 19. It was meant for only that question. Okay, you're not supposed to use the same data ahead. So if R gets at least 2 more coins than S, okay, if R gets at least 2 more than S, so R is more than S, that is true, because that is given in the main question. Okay, so if R gets 2 more than S at least, okay, so R can be here, S will be here, 2 more, S will be here, R will be here. There can be no position otherwise. Again, two cases you have. Okay, this is brilliant. Let's move further. Which is following necessary true? Q gets at least more than s, two more than s. Now in this case, Q cannot get two more than s. At least two. So you have Q here and P here because Q is more than P. So this is perfectly fine. At least two more. But in this case, Q will be next to S. Okay. So cannot be true. Okay. Let's talk further. So let's go to the next option. Q gets more than P. In this case, I mean, Q gets more than P is anyway true. Okay. So that should be the answer. In fact, P gets more than S. Uh, in this case, P gets more than S, but in this case, P doesn't get more than S. So that cannot be the answer. And P and Q get at least 5 coins. P and Q get at least 5 coins. In this case, it is true. In this case, it is not. So the answer is, in fact, this is not even a question because definitely the given data. Okay. If Q gets fewer coins than R, let's talk about that. If Q gets fewer coins than R, now R has to be more than S and Q has to be more than P. So they cannot be one. So the condition says if Q gets fewer coins than R, so Q can be here, okay, and R will be here. In that case, S will be here and P will be here. So Q gets lesser than R. Otherwise, Q can be here, okay, R will be here, and P and S can be anywhere. All right. This is like a logical ability again. With a very simple question, okay? Because here's the following: P and Q get at least 4 coins. Let's look at P and Q in both cases. P and Q in this case get 6 coins. Yeah, at least more than four. P and Q in this case, in any case, in fact, P and Q 5 here and 4 here. So first option definitely suits. Let's look at the other options too, so that we get a clarity why they are not true. Q and S get at least 4 coins. So Q and S in this case are getting only 3 coins, so it's eliminated. All right. Let's talk further. Next question. Next option. R and S get at least 5 coins. So R and S. Look at R and S. R and S in this case get only 4 coins, so cannot be the answer. And the last one says P and R at least 5 coins. P and R at least 5 coins. P and R in this case get at least seven, and P and R in this both the cases get at least five. So I think both the options. A little ambiguity here. I think both the options are correct. Okay, so we'll give this a review as well. All right, now look at this question. Now, in this question is very brilliant question. Okay, if you might have an idea, so let me just look at any queries that you have. Okay, all right. So, okay. So peak concurrent 35. That's really nice. Let's let's talk further. Young girl Rupa leaves home with X flowers. A brilliant question. Now this is like uh, the temple question. Keep in mind there's a person who goes to first temple T1, there's a person who goes to the next temple, the same person obviously, T2, and the last temple 3-3. Okay, now there's a river here, and he comes out. He buys flowers from here, goes in this river. The river is a magical river, doubles the flowers, delivers, offers some flowers to temple 1. Okay, comes out, again has to go to river, again double it, again has to go to river, offers something, again has to go to river, doubles it, and offers something, and comes out with nothing. Okay, I think that's the question. A typical flower question, 2008 cat kind of question. Young girl Rupa lives from home with X flowers, goes to bank of river, nearby river. On a bank of river there are 4 places to worship. She dips X flowers, the number of flowers double. Yeah, perfectly fine. She then makes place of worship, white flower delay. She dips up, blah 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 blah, whatever. Okay, the question is very simple. The concept is very simple. All that we got to look at, the focus is the number of temples. Okay, always you'll start with 2 raised to n minus 1 flowers. So if there are 3 temples, for example, in this situation that I've taken 3 temples, okay, 1, 2, and 3. Okay, you start with 7 flowers because 2 cubed minus 1 is 7. Okay, now see the magic. 7 doubles 14. You'll always offer 2 power n flowers. 2 power n is basically here 2 cube, which is 8 flowers. Okay, so 7 doubles 14. You offer 8. You left with 6. Again gets double 12. You offer 8. You left with 4. Again gets double 8. You offer 8. They left with nothing. Not a very simple equation. Okay, you can do the equation as well, but generally you can just like generalize this saying there's powers of 2 because they're already doubling. The reason is the doubles. 3 times doubles, so it's 2 cube. Okay, so now 4 temples as the condition says, so it's going to be 16. and the number of flowers start with will be 15, and you can get all three answers in place. The same thing that I mentioned. Okay, you got to be like always and always, okay, um, getting at least 5 to 7 questions which you might have seen before or you might know the logic of. So 30 flowers to start with. If 30 flowers start with, the answer must be 32. This is a non-MCQ answer, so 32. Okay, because the number of flowers start with and the number of flowers you offer starting with and offering will be in the same ratio. So start with 30, you'll offer 32. Okay, so that's precisely the answer, and we can go ahead. Minimum flower could be offered to each GT is, oh, minimum flower to be offered to each GT is 15, because that's the basic ratio. 50, I'm so sorry, not 15. 15 you start with, minimum you start with 15, but minimum you offer is 16, because once you start with 15, again magical, okay, 15, and it's doubled 30, you offer 16, so you're left with 14, and it doubles again 28, you offer 16, you left with 12, okay, it doubles again 24, you offer 16, left with 8, doubles 16, and you leave empty. All right, that's pretty cool. Let's go ahead. Leaves home. Oh, wow. This is like a bonus for you guys. Okay. If you know this question and the concept, it's very simple. Okay. Again, 25, 34, we can probably look at it later if you see some other question. Now again, this is like a one liner. It's just given instructions. Now, okay. Let's look at the instructions. F of xy is mod x plus y. F of xy is minus f of xy, and g of f of xy is minus f of xy. Okay. Let's understand this. Okay. Now, when I say f of xy, let's say f of 2 comma 3, what is going to be? Mod of 2 plus 3. What is mod of 2 plus 3? Mod of 5. Positive mod, you get the same result. If f were minus 4 and 3, okay, it will give mod of minus 4 plus 3, which is minus 1 mod is 1, something like that. All right, so you can just assume values and solve for this. Okay, now I'll explain the second function too. F of xy is minus f of xy. Now this says, let's say if I have an example, okay, f of 2 comma 3. Okay, now this will be minus f of 2 comma 3. All right, what will this do is, forget the minus for a while. What is f of 2 comma 3? It is mod of 2 plus 3. Okay, which is mod of 5, which is 5, but it'll negate the sign, so minus 5. All right, and when you have g of f of xy is minus f of xy. So I'll write this down. Let's say if I have g of, let's say if I have g of uh, f of x comma y, f of x comma y, and the output x comma y. Instead of taking x comma y, I always believe like ignore variables and take numbers. 3 comma 4, let's say. Okay, this is going to be minus, sorry for that, this is going to be minus f of xy. Okay, let's look at that first. Okay, so it is going to be, I'll just like close this. Okay, it is going to be minus f of xy. So how do we write this down? Let's say if I have g of x, something like that. So it's going to be f of minus f of 3 comma 4. Now what is, always in functions, remember, always start from the inside and then go outside. What is f of 3 comma 4? F of 3 comma 4 is going to be mod of 3 plus 4, which is 7. Right, now if I say minus f, what is f? F exactly is basically minus of f of same thing. Okay, so it is going to be minus of f of 7. Now if it's just one variable, it'll be minus 7 straight. All right, and with this you can use numbers here, and you can just solve this and go ahead. 3 questions as bonus again, and take care of that. Question number 31, let's look at that. Okay, for a while, I mean, it's a diagrammatical question. Let's look at that. 31, 30, whatever. The road network shown connects all the roads. D is the midpoint. Okay, so BD is the median basically. If D is the midpoint, BD is the median. Okay, uh, AB, BC right angles. AB is 100, so this is 100. They leave at 8 and they take journey to C and take same time. I mean, this guy runs from A to C, the other guy runs from A, B, C. Okay, and they take the same time to reach C. Very simple question. You can try Doing the same thing by the logic that I explained you. Y takes direct route AC and travels 45 per hour on AD, 45 per hour on AD, and 55 per hour on DC. Now the distance traveled is same. So what is the average speed going to be? The average speed is going to be, since the distance traveled is same, is going to be 45 plus 55 by 2, which is 50 kilometers an hour. Okay, so you can answer that very easily and quickly. Okay, 50 kilometers per hour is going to be distance time. I mean the average speed. Okay. These two questions I've kept on review, and look at the last question. Let's look at the last question. Raju reaches from very nice question again. Raju reaches from A to. I mean, I have a touch screen, so I can just zoom it down. I'm so sorry for the diagrams, because we will, from the next mock, we'll have bigger diagrams than what we have right now. All right. Rajiv reaches from A to B, from city B to city A in 4 hours, whatever. Okay. Aditi follows same route, travels at three different speeds, covering equal distance. Two cars, similar petrol consumption. So, because basically, if two cars, similar petrol consumption, we don't read Rajiv even for, okay? Because the question is on Aditi. Petrol consumed by Aditi for the journey is. Now, Aditi, now look at the graph. On the x-axis, you have speed in kilometers per hour. On the y-axis, you have mileage. Okay. So on the x-axis, you have speed. What is the speed of Aditi? 30 for the first hour. So mileage is going to be 16. 16 is basically she can make 16 kilometers per hour as the mileage. Okay. 40 on 24 and 50 on 16. So all you got to do is very simple question. 30 on 16 plus 40 on 24 plus 50 on, what are the given data? 16 again. Okay. So you can just take the, I mean, since you have a calci now, okay, just take the LCM as 48, and it's going to be 3 times, 2 times, and 3 times, and that'll be the answer. I think it comes to around 6.66. Okay. So I can just enter that. Sorry for this. You can just enter 6.66. Okay. And just click mark this, and we're done. Anyway, coming back. So again, we have a lot of greens here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's go back. Now look at this question. A very beautiful question. Okay. How do you solve it? Okay. Now we have one equation, as I mentioned in the initial, like the first thing I mentioned was we have one equation and two variables. Now when you have one equation and two variables, okay, I'll just write the data down. Okay. 4x minus 17 is 1. Okay. And x is less than equal to 1000. Okay. Cool. That's really nice. Let's talk. Let me explain you what special equations are. We haven't done this in class by far. We're going to do this very soon. All right. So just giving you a glimpse of it, a little introduction. Let's say we have some special equation. 2x plus 3y is 17. Find how many values can x and y assume. Obviously, explain that to you. There's going to be a graph. Okay, in this manner. Okay. Now this graph will have infinite solutions. Okay. We can make it finite. Okay. Only by setting limits. Okay, we can set a limit. I want the solution only to be from this point to this point. This is called non-negative solutions. Okay, non-negative means I don't want negatives neither. I mean, I don't want negatives in y, nor any negatives in x. Okay. So here is negative y because the y-axis is going to be negative, and here the x-axis is going to be negative. Okay, so we don't want that, so we say non-negative. Further, non-negative is also infinite, so we say non-negative integral. Okay, because you want integer solutions. All right, only the specific points. Both should be integers. All right, but in special equations, that's not a constraint. They'll probably give you a constraint on either x or y. For example, in this question, they've given a constraint on x because x is less than or equal to 1000. Okay, let's talk. So first, understand how this works. What you do is you use something called as modulo. Okay, what is modulo? Okay, let's say for example, for starters, let's say this is 18, or not 18. Let's say this is 20. Right? So I do modulo 2 across, which means I divide this by 2, divide this by 2, divide this by 2. Here, if I divide by 2, if I divide 2x by 2, I get the remainder 0 irrespective of x. Okay. If I divide 3y by 2, I will not get a 0 remainder. But if I divide 20 by 2, I get a remainder 0. Now, remainder is 0 here, remainder is 0 here, which means remainder has to be 0 here. Now, 3 cannot give me an element of 2 because 3 is an odd number. So y has to give me an element of 2. So y can only take even values, which is multiples of 2. So I can take 0. If y is 0, x is 10. If I can take 2, if y is 2, which is 6, and x becomes 7. When y is 4, Okay, again, multiple of 2 becomes 12, x becomes 4, okay, because 12, 20 is going to be 8. Y is 6, x becomes 1, okay, things like that. And it'll keep continuing. Again, infinite solutions for the same reason. Now, notice carefully one thing here is the values of y increment as the coefficient of x, and the values of x decrement as the coefficient of y. Why is there an increment here and a decrement here? Okay, let's understand that. Because of the reason that there's a plus sign here. So since where there is a plus sign in any given equation, okay, what happens is the equation or the line is going to be this way. So when x increases, okay, now I see if you notice carefully, x is small here, a little more, little more, little more. Y on the other hand keeps decreasing. All right, so that's why you have a negatively sloped line, okay, which is one increases, the other. Negative slope basically means one goes up, the other goes down. Okay, don't worry about slopes. Okay, if in case you're like non-engineer and stuff, chill. It's just a name. Okay, yeah. The point is, one increases, the other goes down. It's going to be negative because it's opposite moments. Okay, all right. Now, if I have something like, let's say, x minus 2y is 10. All right. Now here, if I do modulo 2, okay, I get, sorry, remainder 0 here, a remainder 0 here. So this has to give me a remainder 0. So this can have only and only multiples of 2 as values. Sorry for that. So when x is 0, y is going to be minus 5. When x is 2, y is going to be minus 4. Okay, when x is 2, this goes here, minus 4. When x is 4, y is going to be minus 3. Notice carefully, when the value of y increases as the coefficient of x is 1, the value of x increases as the coefficient of y. So the negative sign, the graph will precisely look like this. Okay, so when the value of x value of x goes up, okay, the value of y also goes up. Okay, we will use the same thing in this particular question. Now let's see what is given to us. Okay, the question says that 4x minus 17y is equal to 1 and x is less than. So obviously, because these values can keep going infinitely, okay? For example, in this case, if something like, if let's say x is 1000, we can still have some valid value of y. If x is 15,000, we can still have some valid value of y. If x is 1 lakh, we can still have some valid value of y. The point is, it's a straight line. It'll keep going solution wise, okay? So we have to have constraints. Now, first constraint that is given in the question is positive integral valued pairs. So one thing is that the line is in this manner. We do not want these values. We are ignoring these values. We just want values from here to here or wherever, but they should be only positive. Okay. But again, if you notice carefully, if they are still kept positive and integers, they can still extend till infinite. So we'll set some parameter, some constraint for one of these variables, either x or y, and say that we only want values till this point. Okay. So that we have a finite answer. Okay. And the equation goes this way: 4x minus 17y is equal to 1. Okay. Is equal to 1. You're supposed to find out x is less than or equal to 1000. So x can go only till 1000 and we need positive values. Right. Let's do some modulo here. Now, if I divide this by 4, all right, let's say, just in case, I mean, I'll teach this to you in detail in the class when we have special equations. Okay, just give you an example right now. For the mock, the remainder is going to be 0. If I divide this by 4, the remainder with 17 is going to be 1, but why, I don't know. If divided by 4, remainder 1. Okay, so 1 minus 1 should be 1. I mean, 1 minus 0 minus 1 should be 1, which is not possible. Okay, so I will have to have a value of y such that I get the net remainder is 1. So I'll explain this to you in detail. Okay, so let's keep this 4x. Now, since x is a constraint, I'll keep 17y plus 1 here. Okay, so I just move 17y on that side, and let's see now modulo 4. So modulo 4, modulo 4, modulo 4. Okay, now 1 is a constant, so it'll give a remainder 1 every time, obviously, with the static number. Okay, this gives a remainder 0, so this has to give a remainder of 3, which means 17 into y by 4 must give a remainder of 3, because only then 1 plus 3 will give you a 4, which is actually a remainder of 0. Okay, so 1 plus 3 is remainder 4, which is 0. Okay, 17 gives a remainder of 1. Y gives a remainder of, I don't know. Okay, but since I want a remainder of 3, 1 into 3 can only satisfy, which means y has to be a multiple of 3. Okay, it's 3 into some number. Uh, I'm sure this is clear right now. Okay, so y has to be a multiple of 3. So let's find values of y that are multiples of 3. Okay, so 4x, I'll start with the first multiple of 3 is 3 itself. So y can be 3 plus 1, and I can get a valid value of x. In this case, the x, I'll find the x value. So in this case, 51 plus 1, 52. So x value is going to be 13. So we can have the first value of x is 13, and the first value of y is 3. Now, since this is a negative equation initially, which is 4x minus 17, y is 13. I mean 1, sorry. Okay, it's a negative equation. Both of them will increase. Keep in mind, it's a positively sloped thing. As I explained earlier, when it's negative, if x increases, y increases. Okay, so if you notice carefully here, x goes up, y goes up. Okay, so x will go up with the coefficient of y, and y will go with the coefficient of x. The coefficient of y is 17. So x will go up like this: 13, then it'll go 30, then it'll go 40, 47, etc. Okay, now but we have a constraint on x. The constraint of n on x is x should be positive. The least positive is 13, because x could have a value of minus 4 as well, but the least positive is 13. Okay, because we need positive values. Okay, so start with 13 and follow some 17x, 17a, I'd say, because it keeps increasing by 17. Now this should be less than 1000, because they say that x is, the question reads x is less than or equal to 1000. Okay, so I'll just say 17a multiple of 17 must be less than 987. Okay, 1020, now you can use the calci here, but I know a couple of things. 1020 is 17 into 60. 1003 is 17 into 59, and 986 is 17 into 58. So I can have 58 values of x. All right, which means corresponding I can have, because y doesn't have a constraint, corresponding I can have 58 values of y as well. So the answer is 58. I hope this is clear, because it's a very simple question again. I mean, you can definitely do it by yourself. Okay, so that precisely, I think, yeah, 25, 26, 27. These three questions again on review. Okay, that's how this is done. All right, let's look at geometry question where we left earlier. Yeah, this is a question here. Now what you can do is you can start assuming a value of a diameter. Okay, any diameter you want. Let's say you want to assume the value of the outside diameter, the outer diameter. Okay, let's say you want to assume the value here as, let's say, 2. Okay, or whatever your choice is. Okay, now if this is sorry, not the diameter, sorry, the radius. Okay, so this is 2. There's a square inside it. Sorry for this. There's a square inside it. Okay, so this is going to be 4. Once you have the diagonal as 4, diagonal is root 2 inside, so you get side. Okay, you can side. Once you get a side, the inner circle inside this, I mean the circumscribing this. Okay, once you have this side, you know half of the side, you can find that radius. Okay, so you can find the diagonal. Okay, or rather, this side is going to be half of the side, because this is equal to half of the side. Okay, it's going to be exactly half of the side of the square. And if you have a square inside this, since you got to know the radius of this, okay, you can easily find the same thing again. Okay, the diameter, and then go ahead with that. Okay, very simple. Again, you'll easily get the answer as pi by 2. Let's go ahead. Anything that we missed out on? Yeah, you can try this. Very simple. Navjeevan Express question is very easy. You can try that. Okay, yeah, this question number 17. This is a cat question. There is a circle of radius 1 centimeter. Each member, where n is the number of sides, is circumscribing the circle. Each member is inscribed in the circle. Let L1 denote the perimeters. You can take one of them, and I think that should be sorted. Then L1 13. L1 13 means basically n is equal to 13. Okay, plus 2 pi. This should be 2 pi here. Okay, the pi is missing here. 2 pi divided by L2 17 is how much? Okay, so L1 13, L2 17. Instead of 13 and 17, you can take something like 4 and 5. Okay, not a big deal at all. Okay, so let's say if we take, let's say, just a minute. Let's say if we take 4 and 6 here, basically. Okay, so 4 and plus 17, 13, 17 is like difference of 4. Okay, so we have a circle. Inside this we have a 4. Okay, outside this we have an 8. Okay, we can make an 8 here. Okay, the question is, you're supposed to find out the perimeter, because in this kind of questions you need not take the same numbers 13 and 17. You can create your own question. Okay, instead of 13 17, you can take any two numbers that differ by 4. So maybe 4 and 8 or something like that. Okay, uh perimeters corresponding polygons, then L1 13 plus 3. Okay, plus L2 is basically, okay, L2 is basically a polygon. Second one, 17 is how much? Okay, 2 pi is basically 13 plus 2 pi. Okay, so if I have a square, the perimeter, I can just assume the radius to be like, the radius is 1, so you can easily find out the diameter to be 2, and then you can find the side because root 2 into side. Okay, you can find the side. Okay, and the perimeter outside here, so very obvious that the perimeter inside, okay, will be a little more than the perimeter outside. Okay, because the 2 pi, the circumference of the circle, is basically speaking, if I have something like this. Okay, just making a random figure, don't take it like absolutely. So it's circumscribing this. Okay, now this area is a little extra for the polygon outside, but that area can be compensated with 2 pi because 2 pi is also included. Right, that's the point. But that cannot be like double of it. Okay, so it's going to be more than 1 and less than 2, precisely the answer. Okay, let's look at this. The square field of 5 meters long, compound wall perimeter, triangular area cutoff, compound wall fence border, length of the fence is 100 meters. What is the maximum area? Okay, length of the fence 100 meters. So basically what you're doing is the 500-meter square field. Okay, so 500-meter square field, I'll just make it, sorry, so I'll just make this, there's a 500-meter square field. Okay, and there's something cut off here by 100 meters, there's 100 meters. Okay, and maximum area here, technically maximum area is equilateral triangles, but since this is 90 degrees, maximum area has to be when these two angles are equal. So it's a 45 45 90 degree. Okay, and then you can easily say the area of 45 45 90 is half base height, or the base height now, because this is going to be by 45 45 90, side opposite 45 degrees is 1 by root 2 the side. So it's going to be half into 1 by root 2 into 100 into 1 by root 2 into 100. It's going to be half again because root 2 is half. So it's going to be half 100 into 100 by 4. It's just very simple. Okay, let's go further. So yeah, I think that precisely finishes off, because 26 to 27, 20, 25 to 27, we kept on review because we've spoken to a technical team, because I found those questions to be a little incomplete with data when the data is concerned. All right. Yeah, this one is still to do. We're supposed to do fourth question. No, fifth question. No, here. Okay. Again, this is a review question because this is like an incomplete one. The question is, at most n candidates selected out of 2n minus 1, 2n plus 1. If number of different view selection of at least one is 63, what are the maximum number of candidates that can be selected for scholarship? Now, when you have, let's say, forget 2n plus 1 and all that. Okay. Now, when I have 7 candidates, let's say, okay, and I want to select, let's say, 3 of them, or maybe like, yeah, 3 of them. Okay, so what I do is I do 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and 7C7. Now the point here is very simple. The entire question is based on odd numbers. Why odd numbers? Because when I make a distribution table of an odd number, the combination table, okay, I can easily divide this into halves. So let's say 7C0, let's just calculate. So this is 1, this is 7. 7C2 is 21, this is 35, this is 35, this is 35, sorry, 21, because C2 is going to be C5. Okay, and this is 1. Now the point is the addition comes to the power of 2. Okay, but half of it comes to another power of 2. So at least 1 comes to, okay, a lesser power of 2. All right. I mean, because you're ignoring 1. So these 4 add to 64, but these 3 add to 63. So if I have 2n plus 1 candidates to be 7, I get n candidates to be 3. Simple. I'm so sorry. It's not a review at all. Okay, very simple question. Okay. Why did we go here? All right. Wait. Sorry. Okay. So I hope you're getting the point here. Okay. Uh, so when at least one is a concern, okay, not for review again. Okay. So the answer is going to be 3 for sure, because 2n plus 1 in that case is 7, because at most n is selected. At most n means what? Maximum n people. Okay. So at most n is going to be till 3. Okay. And at least 1 is 63. So at least 1 is 63, which means these 3 are 63. When at most 1 is selected is 3. At most 1 means half of it. I hope this is fine, clear. Okay. So when let's say instead of 63 we had something like, let's say for example, if we had something like two let's say 255. Okay. So you got to understand one thing. Just double this number. I mean, add 1 to it first. 256. Double this 512, and the power will be the 2n plus 1. So n is going to be 4 in that case. Simple as that. Why is this so? Because it's very simple. 9C0 till 9C9 adds to 250. Sorry, 512. But we're not interested in everyone, because we're interested only in n. Okay. N, if 2n plus 1 is 9, n becomes 4. Okay. So we're interested only till 9C4. Now this adds to 256. But we need at least 1 as well, because this question, the second part of the question says, if the different number of ways selection of at least 1 is 63. At least 1 means 9C0 is ignored. It's just 9C1 to 9C4. Right? And that is going to be obviously 255. All right. So shortcut here is very simple. Okay. Whatever the number is given to you, you'll have this kind of question, very famous. You'll have the question exactly in the same format. All you got to do is take this number down, 63. Okay. Yeah. I'll just do that. So take the number down, 63. Add 1, you get 64. Double it, you get 128. And the power of that is going to be 2n plus 1. So n is going to be 3. Okay, so only 4 questions of review precisely. So we can go ahead. Yeah, these are all done. This is for like the different options have changed, nothing else. Okay, sorry, the data has changed. Let's go ahead, and I think that's precisely it. So yeah, HM cannot be used basically, because the distance is same, I understand, but the point is here it's just the average speed. All right, I still have a look at the question. Question 31. No, it's 58. I just explained that to you a little while back. Okay. Anyway, so that's it. We can meet very soon. We'll meet very soon. We'll meet tomorrow, in fact, very soon. Very soon that we'll meet tomorrow on the same thing, and we'll discuss this at length again. We'll discuss LR at length. Any doubts in today's discussion, please keep them ready and please post them as soon as possible. Uh, Thank you very much. Have a great night. Bye for now.